Okay, if you look at this first problem, we're told Luis is going to paint a basketball court on his driveway, and this is the diagram. And they tell us it's a rectangle and a semicircle, and they want to know what expression represents the area of this court. So all we have to notice in these kind of diagrams is that the rectangle on both sides, of course, has the same length. So that means that this circle has a diameter of 8. So the area rectangle is going to be 80, right? That's the rectangle. And here, right, you can eliminate choice 1 because it's going to be 80 plus this semicircle right here. So the semicircle is half of a circle, and one circle would be what? Well, if the diameter is 8, that means that the radius, this piece right here, is half of that. So the radius equals 4. So that means that a full circle will be pi r squared, or 16 pi, but this is a semicircle, so it's cut in half. So here that means we have 80 plus not 16 pi's, but 8 pi's. And that gives us choice number 2. So that would be an expression for the area. In the next one, we have a rectangle with an area of 24 square units. Okay, so we have a rectangle, right? And we know that the total area, or A, equals 24. The width is 5 units less than the length. So we have a length right here, and the width, whatever it is 5 less than the length. So length minus 5. That would be our width. They want to know what's the length in units of the rectangle. So these questions actually, they all kind of have the same approach. First, we multiply both sides, as we would for area. Pick a different color. So we have length times length minus 5, or length times width, essentially. That's the area, and the area is 24. So what's L times L minus 5? Distributive property is L squared, right? L times L is L squared, minus 5L equals 24. So now we factor this out, but before we do that, we always want to set it equal to 0. That's the easiest way to factor a quadratic like this. So how do we do that? We bring the 24 back to the left side. We subtract 24. And that gets us L squared minus 5L minus 24 equals 0. So we have this quadratic equation, and we're going to factor it. We're going to find what values of L actually work here. 5L minus 24 equals 0. So the general approach in all quadratic equations like this is to hopefully find two factors of this term, the C term, negative 24, that add up to this term, the B term. So C equals negative 24 and B equals negative 5. So what factors of negative 24 add up to negative 25? Add up to negative 5. So we can just start testing, but I'm going to go right for 8, right? I know 8 goes into 24, and I know that if I have negative 8 times positive 3, that gets negative 24. And those are my factors here. You can just list these out until you find them. But I also notice that negative 8 plus 3 is negative 5. So these are the two factors we want to use. They multiply to negative 24, and they add a negative 5. And then the factoring is just always going to be L or X or whatever. And then add the first factor, so plus negative 5, or just minus 5, same thing, times L plus negative L plus 3, right? Oops, sorry, this factor, I lost track. It was L minus 8, right? Because the two factors are negative 8 and 3, so we add negative 8 or subtract 8, and then we add 3. But this equals 0. And when you have two numbers that multiply to 0, these are your two numbers. L plus 3 is one number, L minus 8 is another. They multiply to 0. One of them or both of them should be 0. So we say, okay, let's let them both equal 0. L minus 8 equals 0. And when the second number, L plus 3 equals 0, what does L equal? In the first case, L equals 8. In the second case, L equals negative 3. We can't use a negative length here, right? So that's not an option. That's gone. A negative length wouldn't apply to a rectangle. So the length we need is 8. And then we should test it. So the length is equal to 8, and the width is 5 less than that. The width is equal to 3. And notice that these match the two factors here. So L is equal to 8, and width is equal to 3, and that works because now the width is, oops, where's the 3? If we multiply these two, we do get 24, and the width is 5 less than the length. So here, they want to know what's the length. Sometimes they'll ask for the width, so be careful. The length is equal to 8. All right, let's keep going. So the next one here, we have this logo, and they want to know what's the area of this shaded region, right? Notice that here they say that this consists of a square and 4 quarter circles. So here we're given these measurements, 3 and 3. That means that the square is 6 by 6, right, on each side. So the square area just equals 6 squared, or 36. The circle, if I would just rearrange these into one large circle, right? They're all quarter circles of the same size. So you can find them one at a time, add together, or just draw them all as one larger circle. So I'll sketch that here. That's my circle here. Right, these 4 quarter circles, they're each 3 by 3. Really, they just make one large circle. So we can think of the circle as pi r squared, where the radius is 3, so it's 9 pi. They want to know, expressed in terms of pi, the exact area of the shaded region. So the whole square is 36, and we take 9 pi away to get this shaded region here. Think of that as like, you have the square and you're subtracting the circle area, or cutting them away. And when you cut these 4 quarter circles away, what's left is this cool shaded interior shape. So that's our expression in terms of pi. Alright, let's keep going. Alright, so this one has a bunch of parts, but we'll walk through all of them. So a contractor needs 54 square feet of brick to construct a regular walkway. In other words, that's the area, right? That's how much brick is needed. The area equals 54. The length of the walkway is 15 feet more than the width. So we'll set up a little square here. Oops. Square tool. Okay, or a rectangle, I guess. Here the area is 54. The length is 15 more than the width. So this is width. I'll switch that so it makes sense in terms of being longer. If this is the width and this is the length equals the width plus 15. Okay, write an equation that could be used to determine the dimensions of the walkway. Solve this equation to find the length and width of this walkway. So this is just like the question from before. But here, the equation I would write is W, the width, times the length, which is W plus 15, equals the area. And then what I'm going to do is distribute the W. W times W is W squared, plus W times 15 is 15W, equals 54. Set this equal to 0, that'll make your life easier. So subtract 54 on both sides. So W squared plus 15W, right, minus 54 equals 54 minus 54, that's 0. So now we want to factor this out. And again, this strategy is just the strategy we hope we can use is that factors of this, of negative 54, that's our C term, should add to our B term. So B equals 15. So what factors of negative 54 add up to positive 15? So the factors I'm going to use, and you could list these out to find them, but eventually you'll find that we need 2 factors that multiply to a negative result. So one's positive and one's negative, and when we add them we get a positive result. So to add 2 numbers that get a positive result, if one of them is negative and you get a positive result, that means what? That means the factor that's larger has to be positive. So here I'm going to use plus 18 times negative 3. Now that equals negative 54 when we multiply them, and when you add these 2 numbers you get positive 15. So that means, and we're almost done, if we factor this thing, you can always factor it with the variable W plus the first factor we just found, 18, times W plus the second factor, or minus 3. And that means that if we multiply these two, we do get the expression before. You can test that out. But now we set it equal to 0, so that means these are 2 numbers that are equal to 0. First number and second number. So now, when that happens, we have 2 numbers that multiply to 0. One of them or both of them needs to be 0. So let's assume they both are 0 and see what happens. W plus 18 equals 0. So W equals negative 18 in the first case. In the second case, W minus 3 equals 0, so W equals 3. Now we can't use a negative, right? We cannot use a negative result here for our width. That wouldn't make sense, but we can use a positive result, so we use this one. So our width is 3, and our length is, let's see what it says, I forget. Oh, here it is. The length is the width plus 15. So if the width is 3, right, width equals 3, the length equals 18, right, which is the 2 factors we found here. Okay. Alright, so here we want to find if you read through this, right, you have this playground and these dimensions, they want to know the amount of fencing we'll need. In other words, they want to know the perimeter of the shape. So we have 25 here. This is a rectangle, they tell us, right? Or do they tell us that? Yes, it consists of a rectangle and two semicircles. So this is 25 up here. The semicircles have a diameter of 15, so that means that their radius is 7.5, but if we put these two semicircles together, that's one full circle. And remember that circumference equals diameter times pi. So circumference is like the perimeter of this and this semicircle put together. So diameter is 15, so the circumference is 15 pi. So now for a half circle it would be half that, or semicircle would be half that, but these are two semicircles that make one full circle. So it's just the circumference, right? So it's 50, these two lengths, plus 15 pi. So that's choice number 1. Keep moving. Okay, so Carrie bought new carpet for her living room. She calculated the area of the living room to be 174.2 square feet. So that's the area. The actual area was, so let me write this down. That means that this is her observed value. That's her measurement, right? But the actual value is different. The actual area, equals 149.6 square feet. They want us to find the relative error. So the absolute error is what you would first find. That's how far off your measurement is by subtraction. So here, what are we going to enter? Okay, well, the calculator over here. Well, over here, we have 174.2 minus 149. So you always subtract these two, and you take the absolute value. So you can subtract them in either order, but you should get a positive result here. So my calculation is that you get 24.6 for the absolute error, but relative error, right, is a ratio. So it tells us, okay, how bad is this error? Well, it's always equal to the absolute error over the amount you should have gotten, which is the actual result. So here, that means relative error is your absolute error, 24.6 square feet off, when you should have gotten 149.6 feet, right? So we divide these two. So we get 24.6, 24.6 divided by 149.6, and we get our relative error, 0.1644. So 0.1644 right here, choice 2. Keep going. A window is made of a single piece of glass in the shape of a semicircle. That's right here, this semicircle. And a rectangle, as shown in the diagram below. Here's the rectangle. Okay. Tess is decorating for a party and wants to put a string of lights all the way around the outside edge of the window. So they want us to find the perimeter. And these always have the same kind of strategy, I think, that you can apply, which is that this is 10 over here, so this is 10 over here. That means that your diameter of your semicircle is 10. So the perimeter would involve the rectangle perimeter, which is 12 and 12 and 10, so 34, plus, right, this half circumference. So circumference is just diameter times pi, right? Circumference equals diameter times pi. Our diameter is 10, but so here the circumference of a full circle will be 10 pi. We have a semicircle, so we take half of the circumference, or half of 10 pi, which is 5 pi. So that's our perimeter, but they want to know to the nearest foot what this would be. So on our calculator, we enter in 5 times pi. The pi button's right here, second exponent. Enter, plus 34. So we get this number, 49.7079, and they want to know to the nearest foot. So it's 50 feet. So here our answer would be 50. We round that up. Okay, a couple more to go. Hang in there. Alright, so our last two problems. Okay, this problem says Sarah measures her rectangle bedroom window for a new shade. Her measurements are 36 by 42, and the actual are 36.5 by 42.5. Determine the number of square inches in the area of the window using what? Using the measurements that Sarah took. So that's 36 times 42. Okay. So 36 times 42, we get 1,512. And that's square inches. Determine the number of square inches, the actual area of the window. So what we should have gotten is 36.5 by 42.5. Okay, so 36.5 times 42.5. We get 1,551.25. 1551.25. Determine the relative error. Well, absolute error, if they ever ask you that, is just the absolute value of the difference of these two. In other words, subtract the larger from the smaller, right, to get a positive result here. So it's 1551.25 minus 1512. So this is literally, how many square inches were you off by? 39.25 square inches. Okay, and they want to know what the relative error is. That means, how bad is this mistake in terms of what you should have gotten. So the relative error is 39.25, that's absolute error, out of what you should have actually got. Right, so it's a percentage in a way, right? We usually do it as decimals. So here, 39.25 divided by 155, oops, fix that, 39.25 divided by 1551.25. Oof, okay. It's 0.0253, and they want this to the nearest thousandth, so 10 hundred thousandth. Instead of 0.253, it would be 0.25. So here, we're 0.025 off in terms of relative error. So, right, if you want to find that as a percent, you can multiply it by 100. It's about 2.5% off. All right, last problem. Here they give us these shapes, and what do they want us to do? Let's see. They calculate the area of the trapezoid. Okay, great. So what do they tell us? The circumference of the circle is 16 pi. So if the circumference is 16 pi, and circumference equals diameter times pi, then 16 is our diameter, right? That was the diameter they used. So D equals 16. That also means that in our diagram, this is our diameter, AD is 16. It's going to be the base of the trapezoid. Alright, what else do they tell us? The length of BC is 3/4 the length of diameter AD. Okay, so that means that BC equals 3/4 or 3/4 of 16. So we multiply. So what's 3/4 of 16? Well, I think of 16, I think of a fourth of 16, which is 4, and then multiply that by 3 to get 12. So BC is 12. Okay. And what else? AD and CE are 4 inches. Oh, okay. So AD, oh sorry, CE is 4 inches, not AD. CE is 4. All right. So we're almost ready to solve this one. We just need to find a couple of things. This length right here, ED, well, that equals AD, the total length right here, minus BC. So that's 16 minus 12, or 4. Okay. So here, this is equal to 4 as well, which doesn't seem that way, but these things aren't usually drawn to scale. So if that's 4 and this is 4, we can now find CD using the Pythagorean theorem. So we could recognize that this is a 45, 45, 90 triangle, but let's just use the Pythagorean theorem. 4 squared plus 4 squared equals CD squared, that hypotenuse squared. So 4 squared plus 4 squared is 16 plus 16, or 32. So I'm going to actually leave I'll leave it as radical 32, but we could simplify that to 4 times the square root of 2, because, right, you can break out 32, its factors are 16 times 2, square root of 16 is 4, but I think it's going to be easier to work with this number. And actually, now I'm realizing, what am I doing? We don't even need that, do we? Because I apologize. So all these steps right here, if we were finding the perimeter of the trapezoid, that would be useful. But I just got carried away there with one strategy and wasn't checking to think what I'm doing. Remember with the trapezoid, what you're really doing is you're finding the sum of the two bases, base 1 and base 2. You're multiplying that by the height, and then you're dividing by 2. So you can break the formula down in different ways. I'll use it this way. We don't need this length right here. This is not the height. The height's 4. So base 1 plus base 2, it's 16 plus 12, right? Times the height, which is 4, divided by 2. You can mess around with the order here. Dividing by 2 is multiplying by a half. So I'm going to think of 4 divided by 2 as 2. And you have 16 plus 12, it's 28 times 2, which is 56 square inches. That's our answer for the area of a trapezoid. Sorry, I got sidetracked there. But now you're ready. I mean, if you had to find the perimeter, you could use the Pythagorean theorem in this way to get these sides. All right, hope that helped.